get the idea, basic ideas like what we had. So what we had, the mathematical induction, what all you studied, no? So that only what happened, we are going to implement here as a logic gates here. So just recollect logic or logic kind. Is it completed for you? Mathematics, mathematical induction. Oh, okay, fine, fine. I'll
Next
go in
next
detail.
next week.
Next week, fine, fine. Okay, no. I'll go in detail, no problem. So that's what we are going to, what all you study, okay, it's going to help you in mathematics, fine. This one. So physically, how that logic is implemented, I'm going to teach here. So already we know diode, forward bias, reverse bias, the transistor. So using those basic diodes or transistor only, we are going to implement this logic. Okay, I'll begin with first logic or operation. Okay, first we'll study this circuit here. So basically logic or means, so first I'll make it A as 0 volt. I think the diagram has become a little bit big. We'll make it small. This one. So first the input A and B here logic 0. See, like I'm trying to introduce this one. Logic 0. Logic 0 we define by, so what it is, logic 0 is equal to, shall I write like this? Logic 0 it is. Logic 0, it is defined by 0 volt. The logic 1, the logic 1 will depend by 5 volt. Of course, even not exactly 5 volt, anything around more than 3.8, we take it logic 1. Anything the value from 0 to even till around 0.8 is taken as logic 0, that one. So exactly 0 only logic 0 volt only logic 0, not like that. Okay, I'm saying that one. So if you look at the practically, so this is theoretical. Practically what will happen? Practically logic 0, anything the value ranges from 0 to 0 volt to 0.8 volt, and the logic 1, the value will range from 5 volt to 3.8. In between what happened, we don't know, that we are going to live for the probability of the circuit and we are going to generate it. The in between, I don't know. That means like what happens if 3 volt, 2.5 volt. Okay, we do have another circuits which will cross check. So what can happen, that one and all, we have methods here. So let's not, that is not our problem. Okay, what all we encounter situations of these kind. Anything 0 to 0.8, you have to take that to be logic 0. Anything from 5 volt to 3.8, that you are going to take it as logic 1. So this is the main central idea of our discussion. Since if you look at the ideal, so this will be ideal, this will be practical, so this will be, you can say, ideal. Okay, now how to implement, first what happened, logic or gate. What is OR gate? OR gate logic, how it will be implemented. So what is the output? Output will be y equal to a plus b. This plus sign is not like a addition, it's like a logic OR symbol. So what do this plus sign indicates? The plus sign indicates you can select a plus sign. indicates logic or operation. See now what all we have, our world now has become very, you can say simplified. No, I'm saying simplified. Now you look at the television, so much thing we are able to control. No, even what all we have the Zoom classes. No, because of this logic analysis only, or what you can call better Boolean algebra. Boolean algebra. Later I'll call it as everything as Boolean algebra. And this logic is something very very essential. Even what happened after, I think in the 18th century it was added Boolean algebra, as like somewhere in the 18th, like 1850 afterwards it has come. Then after diodes everything we started implementing this one, and it has become very simple. You can see what all we have automatic, we say no machines, everything is automatic. It's because of this logic thing only, logic gates only. Okay, let's how to implement this logic or operation. I have a diode, this is a resistor, this one. So first I'll make it A equal to 0 volt. A equal to 0 volt means how much it will be? Both the diodes what happen? Unbiased, no? There is nothing called like a voltage. And what will be Y? V naught will be 0. A equal to 0 means what happen? It should be logic 0, no? 0 means what I'm going to do? I'm going to earth it. 0 volt. So what will happen to the output voltage V naught? Should be 0. So for first thing, A equal to 0, B equal to 0. So what do you mean by that? Logic 0 it is. So I should make 0 volt and 0 volt. So for that the circuit will be, the first circuit, no, I'll just show it. So what we are going to do is, I'm going to earth them. If you earth it, how much it will become? 0 and 0, no? So that 0 volt, logic 0, I'll indicate like this. Then how much of output voltage? What do you expect output voltage? Nothing, no, there is no supply, no. So what do you expect output voltage? Will be 0 volt. So then Y is what I'm going to measure. This Y is nothing but the output voltage. That one. So what is the value of Y? Y will be 0. So for the first operation, I'm going to fill up this. For 0, 0, we are getting this is 0. Okay, let me take next one. Second case, I'll make it second one. A0, A as logic 0, B as logic 1. B logic 1 means what I should do? I should connect this to a cell of 5 volt. So how do I can bring cell? I think I'll just directly connect a cell 5 volt. And because of this, what will happen to, okay, these are the diodes. So both D1, D2, shall we say unbiased? Now whatever D1, biased or unbiased? D1. D1 is unbiased. What about D2? D2 is forward biased. If D2 is forward biased, then anything will happen. What can be the output voltage? So our concern is like, hey, what should be the output voltage of that one? So now if this is forward bias, a current will flow. So what is the state of this? D1 is unbiased, D2 is forward bias. If D2 is forward bias, a current will flow. This current will flow like this, and it will flow here. So then let's take this diode. Even if you take 0.7 volt, how much drop V naught should be? I think you know enough of KVL. Apply KVL. This is the first problem. Plus 5 volt. I think I can slide up. Plus 5 volt. Minus VBE. minus I into R equal to 0. So if I assume VBE 0, let's take ideal case. Huh? So how much IR? So in place of IR, okay, let's substitute all the values. IR is nothing but V naught, no? So what is V naught? 5 volt. What is V naught? V naught 5 volt is nothing but the value of Y. So what should be the value of Y? V naught 5 volt means logic 1 or logic 0? Logic 1 it should be. So I think I had to show that logic 1 like this here. It should be like this. Okay, able to get this one. So therefore now for 0, 1, what we are getting? We are getting here 1. Don't write 5 as 0 plus 5, 5. No. 5 volt is 1, logic 1. Now similarly, let me connect this to a cell. Okay, this will be like this. So what is the logic here? Logic will be 1, then 1. This will be 5. How this current I will flow like this. Similarly, if I go and calculate here, the same situation here. Here also the same situation. V not equal to 5 volt. What is the state of diode D1? D1 is forward bias, D2 is unbiased. So therefore, what is the column? 1, 0. Logic A is logic 1, B is logic 0. We'll get 1. When both are, for both the things, I'll apply it. No. Okay, looking at this, what will be the current? They're parallel, no? Two cells are in parallel. Don't again write two cells are in parallel. Okay, find this one. So how much of output voltage will be? 5 volt. How much of current, how much output voltage will be? 5 volt. So this will be logic 1. So what is the condition now? This will be 191. This will be 1. So this is a OR operation, logic OR operation. So what is the thing? This is also called as low and high. Instead of 0, they're telling low. So one more representation of this is what? Like a 0 means low, 1 means high. When both the inputs are 0, logic 0, what will be the output? Will be logic 0. If any one input is high or both inputs are high, what will be the output? Output will be high. Some logic we have brought it, no? Sir, what is the logic? What? I'm not seeing any logic. This is what? When both the inputs are low, output will be low. Any one input or both the inputs are high, output will be high. So this logic is what I brought. How do I implement it? By using diode. Okay, this is what we discussed here. So what is the logic OR operation? So I think I'll write it here. That one. 0 means low. I think in mathematics you are going to learn like this. You are not going to learn 0, logic 1. You are going to learn low and high. When both inputs are low, output will be low. So directly, I think there no diode, nothing. Directly, the mathematics teacher will bring you the logic directly here. Here, what happened? I'm started with an example. So how do that logic or operation you can implement by using this circuit? What is the logic or operation? What is the conclusion we can make it? So when both the inputs are low, logic or operation. What is the meaning of that? Logic or operation. What it says? when both the inputs are low, the output will be low. This is one thing. Next again, second one, when any one input or both inputs are high, the output will be high. So there's a basic idea of the logic or operation. Now, once again, what do you mean by low? Logic 0. What do you mean by high? Logic 1. Since you said in maths not got over, no, so your maths teacher I think will start like this, huh? L you will write like a hell h, then you write h will be h. So why you are writing like this? Logic or operation. So I think the first time you come across, just start accepting it, you'll be in comfortable position. Okay, this is our logic gate. Yeah, I'll scroll down, just if you want you can see once. Okay, next we'll go for another operation called as a logic hind operation. Or now you can ask question like, so what is this? You're drawn some symbol. This called like a gate, circuit symbol, or gate we say. Sir, gate. What do you mean by gate? That's what we say it like that. Because through it, what happen? We implement logic. No, we'll call some sort of like a gate, or gate we say. So why that gate symbol? So this instead of every time drawing diode, resistor, all this one, no, I just show like this here. Got this? So when we discuss numericals, no, we'll be using this symbol. This is a circuit symbol. So what is the meaning of this? It's a there's a practical circuit. This is called like a truth table. In mathematics, you call truth table. Truth, the reality. In as far as our engineering is concerned, okay, the okay truth table, whatever you call that one. So how that input output are related, we have a table that in maths we'll call it a truth table. In books they started calling truth table, so let me call that one. Okay, got this. There's a practical circuit, logic or operation, practical circuit using diodes we implement, circuit symbol, and how input outputs are related for this is called. So what is that plus sign? Is it addition? Plus sign indicates logic or operation. I think this is something very important. You should not go for this one. 1 plus 1, don't write 2 here. So some of you will get tempted. Ah, sir, okay, fine, sir. 0 plus 0, 0. 0 plus 1, 1. 1 plus 0, 1. 1 plus 1, sir, 2. You don't have logic. You are good in maths, but you don't have logic. Getting this one? So 1 plus 1 will be 1. Logic 1. It's a plus is here, not addition. It's a logic or operation. Plus sign indicates logic or operation. This is something I think very important. I think government of India is going to introduce from 6th standard only this one, future, because this is something very essential. Definitely, shall I tell you? I think it will enhance your thinking ability. It will enhance your thinking ability, irrespective of. I think anybody can learn. No, this is okay. Leave this, leave this diode everything. But any teacher, I think any student from any age can learn here. This much you can learn. This I think whether you are a commerce arts student or you are a maths engineer, scientist, doctor, or security guard, anybody can learn this. Nothing is there. It's just a logic, no. So there's no any requirement of anything for you. Okay, let's come for logic hind operation. Again,